For question number 7, we have the differential equation derivative of x with respect to t is equal to 1/25 times x minus 4 plus s models a population with stocking at rate s. We want to determine the dependence of the number of critical points c on our parameter s. Due to the way that this is written, we can rewrite this slightly. So let me do that here. This would be the derivative of x with respect to t. We could rewrite this as negative 1/25 times x times 4 minus x plus s. That way we could factor out the negative and we could rewrite it in this format. Which will then correspond then, since for this, we want to use the following formula. H comma n is equal to 1/2 times m plus or minus the square root of, this would be m squared minus 4h divided by k. So here we are going to let k to be negative 1/25, m to be 4, which is why we rewrote that. And then since we have some value h here, that's going to correspond to a negative value of s, since h is supposed to be for harvesting. So this would then give us the following. H comma n is equal to, this will make 1/2 of 4 plus or minus, this will be the square root of, this would be 16 plus 100 times s. But from this, which is based on a quadratic formula, we could pull out a 16 from both of these two terms. So this then makes 1/2 times 4 plus or minus, this would be the square root of 16 times 1, 16 times, this is going to be 1 plus, this is going to be 25/4 times our value of s. Times our value of s. And it should then be noted that taking out that 16 will give us 1/2 times 4 plus or minus 4 times the square root of, this would be 1 plus 25/4 times s. Again, due to the stocking then, in this case. And I should probably make notes, actually. We do not need to make this negative. These could still be negatives as opposed to positives, in order to make it be beneficial for us. Okay, so we have 1/2 times 4 plus or minus 4 times the square root of 1 minus 25/4 times s. This then simplifies to 1/2, excuse me, we want to get rid of the 1/2. This simplifies to 2 plus or minus 2 times the square root of 1 minus 25/4 times s. So from this, we are going to have 3 cases. Case number 1. This is for values of s being greater than 4/25. if we have values of s being greater than this, that will cause this value here to be larger, which then makes underneath the square root a negative number, which means we are going to have complex numbers. Which indicate that there are no critical points. And let me just fix my A then. Critical. We have no critical points because it's negative. Second case, this would be for values of s being equal to 4/25. That gives this value here a 1, gives underneath this square root a value of 0, which then gives us just one critical point, the value of 2. So here we would have one critical point, and as we said before, that value would just be the value of 2. The third case, this is for values of s being less than 4/25. That will then start causing this value here to be greater than 1. This will start giving us values here that will cause this expression underneath here to be positive, right? Since when we get to 0, this just makes a positive 1, and then we start getting into negative values, this will start becoming positive, which then means we would have our 2 critical points. And those correspond with c is equal to 2 plus or minus 2 times the square root of 1 minus 25/4 times whatever our s or stocking rate is. Thank you.